is the quadratic equation. When I put y equals 0, there are two possible values of x. The values of x, let x equals alpha, x equals beta. Only when y equals 0, there are only two possible values of x. Those values of x are called as zeros of this polynomial or roots of this polynomial. This is a polynomial second degree quadratic equation. If you know the quadratic equation, we can find its roots. If you know the quadratic equation, we can find its roots. Roots are alpha and beta by usual factorization method or some other method. If the roots are known, we can verify the relationship between the roots and the coefficients by these two. This is one way of solving the problem. And other type of problem are if the roots are known. If the roots of a quadratic equation are known, then can we be able to write the quadratic equation? Yes, it is possible. The standard form for the quadratic equation, if you know only roots, is, remember this, x square minus x into alpha plus beta plus alpha beta, where alpha beta are the values or roots of the given polynomial or the quadratic equation. So write this equation. This is the equation in terms of roots, its root. Substitute for roots and simplify, you get the quadratic equation with the usual coefficients. Let me see that the solving problems. Let me solve problems on this. The same again. Already I have done one problem. We have solved a problem on this. We see one more problem, a typical problems for this kind of same type we have done. The given quadratic equation is t square minus 5. Find zeros and verify the relationship between the zeros and coefficients. The given is t square minus 5. This is not x. Doesn't matter because the symbols we are using may be any different values. You can use x, t, yeah, or something like m, n. Doesn't matter, or s like this. This is a quadratic equation in terms of the symbols t square. You can also write it as x square minus 5. Doesn't matter. Quadratic equation after this 2 exponent is to quadratic equation. In this term there are only two terms. The t term is not there, x term is not there because its coefficient is 0. Equation for the second term, its coefficient is 0. Only t square minus 5. First and the last term is there. Let us solve. That is, we shall find out the roots of this quadratic equation. So it doesn't require any factorization. Directly we can solve this. Given as t square minus 5 equals 0, put this as 0. When y equals 0 only, it is possible. The possible values of t. If this is the case, then we can write it as. This equation follows this. Take it to right hand side, plus 5. Then t equals square root of 5 with plus or minus. Because t means there are two possible values. T equals plus root 5, t equals minus root 5 possible. So after t square equals 5, t is plus or minus root of 5. It means t as one value root 5, t as another value root minus root 5. Alpha is one root, beta is another root, plus root 5 minus root 5. These are the roots of this polynomial. This is a quadratic equation. So if the roots are known, you go for verification. That is a verification of this relationship. That is alpha plus beta equals minus b by a. Let us verify this. We know alpha and beta, we know b and a. Let us write what is alpha plus beta. Alpha plus beta is equal to root plus root 5 plus beta minus root 5 minus root 5. Minus into minus, minus into plus, second term minus root 5 plus minus cancel 0. So alpha plus beta equals 0. Then let us find out the value of minus b by a. What is b? You look at the equation, right? What is the value of b? I said second value, coefficient of second term. The coefficient second term is 0. It is not there. So b is 0. Minus of 0. What is the coefficient of t square? So first term is 1. There is no value means it is understood coefficient is 1. Minus 0 by 1 equals 0 because minus 0 by everything is always 0. It is 0 value. So 0, 0, it is verified. First equation is verified. And second equation alpha into beta. What is alpha into beta? Plus root 5 into minus root 5 and plus into minus minus root 5 into root 5 5 minus root 5 no minus 5 answer. And let us find the value. This alpha into beta equals c by a. Let us verify this also. Relation between the another relation between roots and coefficient of the quadratic equation. Here c is minus 5 constant. A is 1. C by a minus 5 by 1. So 5 by 1 is 5 minus 5. Minus 5 minus 5. This is also verified. So the relationship is verified. We have find the roots of the quadratic equation and these two relationships, the relationship between them is verified. This is about the problem, the solution of this problem. Let us go for second type of problem. In this, here alpha and beta are given. We shall find out the quadratic equation. I am taking two typical examples for this type of problem. Here, problem 3. If 1 by 2 are the roots of the quadratic equation. Alpha is same, beta is also. It is possible. Alpha, value of alpha is half, value of alpha is 1 by 2. That is, you are given two roots, asking to write quadratic equation. Solution is alpha is equal to 1 by 2, beta is equal to 1 by 2. Write the standard form of the quadratic equation in terms of the roots. X square minus x into alpha plus beta plus alpha beta. Substitute for alpha and beta. Alpha plus 1 by 2 and 1 by 2 equals 0 as it is. 1 by 2 plus 1 by 2 is 1. 1 into x is minus x. 1 by 2 and 1 by 4 is 1 by 4 equals 0. Here fraction is there. Clear the fraction. Multiply the equation throughout by 4 because right hand side 0 is there. Term by term multiply left hand side. First term into 4, 4x square. Second term into 4, minus 4x. Plus 1 by 4 into 4, 1 equals 0 into 4, 0. Equation is reduced to quadratic equation. That is a required quadratic equation with usual coefficients. Here the coefficient of x square. Here 4 plus 4 is the coefficient of x square. Minus 4 is coefficient of x. And c value of c is 1. This is a quadratic equation. So this is how we can able to write the quadratic equation if you know the roots of the equation. That is why if you know the roots, you can write it. So for these roots, quadratic equation. If this equation is given, we can find out alpha beta. If alpha beta is given, we can find out the quadratic equation. Both are possible, reverse, either way. So one more problems on the same type, but here it is not given alpha and beta. Equation problem is different, little different. Alpha beta value is not given separately, but you are given as a sum of the roots. Alpha plus beta is root 2. Product of the roots is 1 by 3. Sum of the roots and the product of the roots are root into 1 by 3 respectively. Find the quadratic equation. Just right away given polynomials of alpha and beta. Standard one. Substitute for alpha beta because alpha is not known, beta is known, but alpha plus beta is known. What is alpha plus beta? Directly given as x into root 2 plus alpha into beta 1 by 3 equals 0, 0. Simplify. Here fraction is there, here clear the fraction. To clear the fraction, multiply throughout by 3. Multiply the equation throughout by 3. See first term into 3, 3x square minus second term into 3, root 2 is already there, 3 into root 2 is the coefficient. It's possible. It's a real value. 3 into root 2 is a real value into x. Plus 1 by 3 into 3 plus 1 equals 0 to 3, 0. So the quadratic equation for this given data 3x square minus 3 root 2 to x plus 1. These are required quadratic equations. So these are the problems we expect in the examination. The one type, give a quadratic equation asking us to calculate its roots, and further if they ask verify the relation between these coefficients and the roots, this is the way you have to follow. That is one way of solving. Other way of solving, reverse. Here the roots are given. With these roots we can able to find out the quadratic. We can able to find out the quadratic equations. So this is a standard one. Write the standard one, substitute for this and simplify. You get the quadratic equation, required quadratic equations. This is how we can solve the problems of this type at the easiest way. That is, even the weaker students can understand. Thank you.